So here we are going to talk about angles. And there are some notations I want you to be aware of. You might want to stop this and take notes at the end. An angle is formed by two rays with the same endpoint. They share the endpoint and they are pointing in different directions. Now, the rays are the sides of the angle, and we call the endpoint where they come together, that's the vertex of the angle. And another way you can think of an angle is simply, it's a measure of how much one ray is rotated around that vertex point away from the other one. And we will be able to quantify or give that a number based on how much rotation it has. Okay? How do you name it? Well, you can name an angle by its vertex. You can say this is angle A. In this case, we can say it's angle A because there's a single angle at vertex A. You can also name it, and particularly if there's more than one angle that has the same vertex, you will need to use three letters. So we'd use a point on each ray, and the vertex angle, or the vertex point rather, is always that center letter. So we would say angle B coming down to the vertex to A and out to C, BAC, or angle C coming to the vertex A and then out to B, angle CAB. And occasionally it'll have a number in it, and in which case we can call that angle 1. Different ways you could name it. And that depends on, again, whether we have a single angle just coming from that vertex in which we can use this. If we have multiple angles going to the same vertex, we would definitely want to be using three letters with the vertex point as the center letter. And if there's a number in there, we can call it just angle 1. The sides of the angle are ray AB, vertex is the endpoint, and ray AC, the vertex is the endpoint. Now, when you name angles using 3 points, as I said, the vertex must go in the middle. Another thing to note is that we will call this the interior of the angle and this everything outside the exterior. Interior of an angle is the region containing all of the points between the two sides of the angle. Remember, these go on for forever, so there's this whole region of space or of this plane that falls within the interior. And the exterior is the region containing all of the points outside of it. So what are the two other names for angle 1? This is angle 1 right here. How could we name this in other ways and it's still the same angle? Well, what rays form angle 1? We have ray MJ and ray MK forming angle 1, and they both have their vertex at M, and so that's going to be the central letter, the middle letter when we name the angle. So we can say here we start at J, go down to M, and up to K. Okay, and we can go the other way as well. We could say we could start at K, go down to M, and up to J. So angle JMK or angle KMJ are both names for angle 1, and you just got to make sure that the vertex is the middle letter as it is here. M is the middle letter. Okay, so now it's your turn to try a got it problem. For this course, we're going to be using degrees to measure angles. There's another way you could measure it called radians, and I'm happy to explain it to anyone if they ask, but we're going to be working with degrees. To indicate the measure of an angle, you write a lowercase m in front of the angle symbol. So while you are talking about angle A here, and it's written like that, this would say the measure of angle A is, and then you would give the measure. Okay? They wrote it out in words here, but you can write it as this. So a circle has 360 degrees, so 1 degree is 1/360th of the entire rotation around a circle. Protractors are used to measure angles, and a protractor forms half a circle and can measure an angle anywhere from 0 to 180 degrees. And we have a postulate for this called the protractor postulate. I apologize if the audio is funny, but consider this. We have ray OB. There's just some ray that's got an endpoint at O, and it runs through B. And then there's some other point, A, that is on one side of OP. We can form another ray from the endpoint O, and instead of going through B, we now go from that endpoint to A. Now, since we have two rays that share an endpoint, we now can think of this as the vertex of the angle formed by these two rays. And every ray of the form ray OA, where A is some point somewhere off of this ray, can be paired with one-to-one with a real number from 0 to 180. So if we were able to plot any point, let's say a point here, we could connect that with O, and we could measure the angle in here. It would be between 0 and 180, or from 0 to 180, right? And you can put a point anywhere. Let's put a point here. Okay? If we put a point there, then we would have connected to O that point, or from endpoint O running through that point, we would form an angle right there, up to 180 degrees. Because essentially what's happening is wherever the point is, we can either go this way to measure it, or we can go this way to measure it, so that the measure is up to 180 degrees. Now, we have this protractor postulate, and we can use it to find the measure of an angle. So check it out. We can take a protractor, we can plop it down onto the vertex right here, this center circle on a protractor, which is right in line with the 0, 180 mark right here. Okay? If we put the vertex there, then both of those rays, ray OD and ray OC in this case, will each land on a number. And we got to stay on the same track, either in the inside or the outside. And if we stay on the track on the inside here, this looks like it's about 32, and this looks like it's about 135. Okay? So they both correspond with a number, and we can then find the measure of angle COD by taking this number that it lands on minus this number, or vice versa. Since we're taking the absolute value of it, one would give us a positive number, subtracting the other from that would give it a negative number, but either way we're going to have a positive outcome because we're taking the absolute value. And it's just like the two numbers on the number line for a segment. If you subtract the two places where a segment has its endpoints on a number line and take the absolute value, you'll find the length of that segment. It's related to that. Okay? So notice that the protractor postulate and the calculation of an angle measure are very similar to the ruler postulate and the calculation of a segment length. There are four types of angles that we're going to be dealing with. An acute angle, it's between 0 and 90. Okay? Greater than 0, we need to have an angle that's greater than 0, and it has to be less than 90. What if it's exactly 90? We call it a right angle. What if it's greater than 90 but less than 180? We will call it an obtuse angle. And what if it's 180? We call it a straight angle. Okay? You notice down here, oh, and of course this is classifications of angles, so we can take any angle and say it's acute, or it's right, or it's obtuse, or it's straight. And we're always going to be measuring the shortest distance. If you were measuring the angle around that way, that would be called a reflex angle, but we're not going to do that. We're going to be measuring this up to 180, measure that side of one of the rays. And when you see this right here, this indicates a 90-degree angle or a right angle. All right, now we're going to measure these angles, and then we're going to classify them. And we're going to use the protractor postulate for this. So when they say, what is the measure of, let's say this one first, angle LKN, we start at L, go down to K, and go over to N. Okay, we're going to look at the two numbers that they're at, and we can do this two ways. Watch. This is really worth noting. We could either be on the inside track, this one's at 0, and this one's at 145. Yeah. Or we could say, what if we were out here at 180? This one's at 180. This one's at 35. Notice that it's between 30 and 40, not after 40, and you could call it 45. You got to see what two numbers it's between because it's actually counting down. Okay, so 180 minus 35, or you could say 0 up to 145. Okay, so here they used 0 and 145, the inside track. You don't have to do it both ways. It's going to give you the same number either way. And when you do 145 minus 0, you get 145. The absolute value of that is 145. That makes it an obtuse angle. Now let's do the next one. JKL, JKL right here. I'm not sure which track they're going to use. Let's say if it was at 35 and 90, we could do that. Or we could do 90 and 145. What did they use? They used 90 and 145. So 90 minus 145 is negative 55. The absolute value of that is 55. And so that angle JKL is a 55-degree angle. It's acute. And finally, they ask about angle JKN. JKN. Okay, 90 and 180 for the outside track, or 90 and 0 for the inside track. They used 90 and 0. Subtracting, you get 90. Absolute value is 90. So angle JKN measures 90 degrees and so is therefore a right angle. All right, here's your got it problem. Pick the multiple choice answer. Which one has the correct measures for these angles and has them classified correctly? All right, just like segments, we can talk about angles being congruent as well. Angles with the same measure are congruent angles. That means if the measure of angle 1 is equal to the measure of angle 2, the number that measures them is equal, then the angles themselves are congruent. Just like I said earlier, me and my brother might have the same measure because we're the same height, but we're not the same person. You can say these two angles are congruent, but you wouldn't say the angles are equal. The measures are equal. You can also say that if angle A rather is congruent to angle B, we can then make the statement that the measure of angle A is equal to the measure of angle B, because that's what congruence means. And of course, this talks about the angle marks. If you put an angle mark here and an angle mark here, we are making a statement of fact about angle A and angle B, that they are congruent and that their measures are equal. If we had another set of angles, and those angles, let's say angle C and angle D, were congruent to each other, but not congruent to these two, angle A and angle B, then angle C and angle D would have two angle marks. So here we have an illustration of synchronized swimmers, and the angles are drawn out here. And the question is, if the measure of angle GHJ right here is 90, what is the measure of angle KLM right here? Okay. The idea here is this. If you have the angle marks, double angle mark here and double angle mark, then they are congruent. They have equal measures. So if this angle measures 90, then so does another angle that has those same marks indicating congruence. Yes? Okay. So here is your got it problem, and good luck. All right, so like the segment addition postulate, the angle addition postulate states that two angles can add together to be a larger angle. Specifically, if point B is in the interior of AOC, so you have this angle, angle AOC, and point B is somewhere in its interior, you can then create a ray from vertex O through B, right? And then you get two angles, angle AOB and angle BOC. The measure of angle AOB plus the measure of angle BOC will be equal to the measure of that larger angle, the measure of angle AOC. All right, so we can use that angle addition postulate and solve problems. We have expressions for the measure of these angles. And so we know that the measure of angle RQT, the larger angle, I should say, is 155. So what are the measures of these two smaller angles? The measures of RQS and TQS. So we know from the angle addition postulate that the measure of RQS plus the measure of angle TQS is going to be equal to what angle RQS, or RQT rather, measures, which is 155. So we can then substitute in the expressions for those angle measures here, here, and here. And we combine like terms to simplify to this. We now are going to add 6 to both sides and then divide both sides by 7, basic algebra. We found that x is equal to 23. So what we need to do now is we need to take these expressions for these angles and we need to substitute in 23 where we see x. So if the measure of angle RQS is 4x minus 20, it's now 4 times 23 minus 20. Simplify that first, then do the subtraction, you get 72. Here, the measure of angle TQS is 3x plus 14, and x is equal to 23, so 3 times 23 plus 14. Multiply here first, then add, and you get 83 for that angle. So now we found those two angles. Okay, your turn to do the got it problem. Okay, if you so choose, do these lesson check problems to gauge your understanding. And once you have your answers down, you can restart and check your answers. Good luck.